Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in lecture number 7 and last lecture for this unit. Paper number IC-506 Synthetic Drugs, unit number 3. In previous lecture, we started last group of drugs, anticoagulant drugs. And in this lecture, we studied about introduction and synthesis of dicumarol. Now, in this lecture, we will discuss about synthesis of tromexan, Fenindion, and Valium and their medicinal application. So, we start with synthesis of tromexan in anticoagulant drugs. Tromexan is also known as Pelentan, or tromexan, and it is synthesized from three starting materials. Here stated that 4-hydroxycoumarin. First structure is 4-hydroxycoumarin. Second is oxoacetic acid or a glyoxylic acid. CHOCOOH, oxoacetic acid or glyoxylic acid, and 4-hydroxycoumarin. So, for tromexan, 2 moles of 4-hydroxycoumarin and glyoxylic acid are treated. In presence of diacetic acid, 2 moles of 4-hydroxycoumarin and oxoacetic acid treated in presence of diacetic acid, we get 4-hydroxy 2-oxo 4-hydrochromen 3 while 4-hydroxy 2-oxo 4A 8A dihydro 2-hydrochromen 3 while acetic acid. We see detailed reaction. The 4-hydrocoumarin, this compound remove hydrogen, here hydrogen, and oxoacetic acid loss or remove oxygen. In presence of 4-hydroxycoumarin, 2 moles of 4-hydroxycoumarin and oxoacetic acid in diacetic acid gives intermediate compound of coumaron, that is 4-hydroxy 2-oxo 4-hydrochromen 3 while 4-hydroxy 2-oxo 4A 8A dihydro 2-hydrochromen 3 while acetic acid. 2 moles of 4-hydroxycoumarin and glyoxylic acid condensate. After this, intermediate compound of coumaron 4-hydroxy, that is 4-hydroxy 2-oxo 2-hydrochromen 3 while 4-hydroxy 2-oxo 4A 8A dihydro 2-hydrochromen 3 while acetic acid is treated with ethanol C2H5OH in presence of sulfuric acid. In presence of sulfuric acid, dehydration process takes place. In presence of sulfuric acid, ethanol remove H and COOH group of coumarin loss OH. Therefore, water molecules remove and we get our final product tromexan. Tromexan, and chemically it is the ester of coumarin derivative. Chemically 4-hydroxy 2-oxo 2-hydrochromane 3-while 4-hydroxy 2-oxo 4A 8A dihydro 2-hydrochromane 3-while acetic acid ethyl ester. In this chemical name, H indicates hydrogen, so we also call it chemically as a 4-hydroxy 2-oxo 2-hydrogen. Here 2 hydrogen. Chromane 3-while 4-hydroxy 2-oxo 4A 8A dihydro 2 hydrogen. It is also 2 hydrogen. Chromane 3-while acetic acid ethyl ester. This is the synthetic route for tromexan and it is derivative of coumarin. Now, medicinal application of tromexan. It has anticoagulant property. Tromexan has anticoagulant property. Number 2, its advantage over bis-hydroxycoumarin appear to be that it is quicker in action, but with a coagulation time that is not so prolonged, and that it is more active but gives rise to favor toxic effect. It is its disadvantage. It gives rise to favor toxic effect. So it is very important and quicker active anticoagulant compound. Now our second compound for this lecture is Fenindion, and Fenindion is synthesized from benzylidene 3 hydrogen isobenzofuran 1 on. It is also known as benzyne phalide. This benzyl phalide or 3-benzylidene 3 hydrogen isobenzofuran 1 on is treated with sodium methoxide and methanol. Methanol and sodium methoxide is treated with benzalphylide gives 2-phenyl acetyl benzoic acid. Here stated structure is 2-phenyl acetyl benzoic acid. This 2-phenyl acetyl benzoic acid is undergone by dehydration process. Water molecules is removed, so we get 2-phenyl indene 1,3 dione, 2-phenyl indene 1,3 dione, and it is known as Fenindion. So by this route, by this synthetic route, we get Fenindion by benzalphylide. Fenindion by benzalphylide. Now, medicinal application of Fenindion. It was the first non-coumarin synthetic compound to be introduced as anticoagulant agent and presumably act in a similar way to bis-hydroxycoumarin. Our compound, this compound Fenindion is non-coumarin derivative. It is non-coumarin derivative. Coumarin derivative have anticoagulant properties. So most of compound are coumarin derivative, but Fenindion is non-coumarin derivative and it is very useful in anticoagulant agent, and also it is similar to bis-hydroxycoumarine. So this is the medicinal application of Fenindion. And last compound for this unit and this lecture is Valium. It is also known as diazepam. Diazepam. Valium or diazepam is synthesized from two compounds. One is 2-amino 5-chlorobenzophenone. Repeat the name, 2-amino 5-chlorobenzophenone. And second is amino acetic acid. Here stated structure is 2-amino 5-chlorobenzophenol. This is benzophenone derivative and this is amino acetic acid. Now these compounds are treated and gives 7-chloro 5-phenyl 1,3-dihydrobenzo E 1,4-diazepine 2-on. We see the detailed reaction. There are condensation process takes place and 2 moles of water is removed in this reaction. One hydrogen atom and one OH from here removes H2O and one other H2O from oxygen from here and 2 hydrogen from here remove 2 moles of water molecules and we get 7-chloro 5-phenyl 1,3-dihydrobenzo E 1,4-diazepine 2-on. This is the synthetic route. 2-amino 5-chlorobenzophenone and amino acetic acid on condensation, removal of 2 moles of hydrogen gives derivative of diazepine. Now this diazepine derivative, that is 7-chloro 5-phenyl 1,3-dihydrobenzo E 1,4-diazepine 2-on is treated with sodium methoxide and methyl iodide, that is CH3ONA, sodium methoxide, and CH3I, methyl iodide, gives our final product Valium. Here methyl group is introduced and this methyl is from methyl iodide. This hydrogen is substituted by CH3. So we get our final product Valium. And chemically Valium is 7-chloro 1-methyl 5-phenyl 1,3-dihydrobenzo E 1,4-diazepine 2-on. We known it as a Valium. This is the synthetic route of Valium from 2-amino 5-chlorobenzophenone and amino acetic acid. This is the synthetic route of Valium. Now we discuss medicinal application of Valium. Number 1, it has anticoagulant properties. And number 2, it is used as anticoagulant drugs. This is medicinal application of Valium. Now we complete here our this drugs class of drugs, anticoagulant drugs. In this class we discuss dicumarol, tromexan, Fenindion and Valium. According to our syllabus, unit number 3 contains one more class of drugs is anti-cancer drugs. And also in unit number 4, last class of drugs is anti-neoplastic drugs. Anti-cancer and anti-neoplastic both are same. Both are same. So, anti-cancer and anti-neoplastic drug we discuss both in unit number 4. So, we here complete our unit number 3. At this time, we completed in this paper synthetic drugs. We completed our 3 units, unit number 1, 2 and 3. And this 3 unit contains different types of class of drugs and their drugs. We synthesize them and we discuss their medicinal application. In next lectures, we will start our unit number 4. Thank you.